Hi students, in part B, solved problems. Topic 9 is short questions. Very short questions are over. Now solutions for short questions. What is the seventh problem? Find LCM and HCF of 336 and 54 by the prime factorization method and verify that LCM into product of LCM and HCF is equal to product of the given numbers. Now prime factorization of 336 and 54. Now prime factorization of 336. You take 336, you take 3, 3 ones are 3, 3 ones are 3, 3 twos are 6. You take try for 3, 3 threes are 9. 9 means 22. It doesn't go. That's why you have to take 2. 2 fives are 10, 2 six are 12. Again, you do with 2. 2 twos are 4, 2 eights are 16. Again, do with 2. 2 14s. 2 7 times. It will go. Now, 336. I will write here 336 is equal to how many? 3 into 2 to the power of 4 into 7. 3 into 2 to the power of 4 into 7. That is prime factorization of 336. Now prime factorization of 54. You take 54. You take 3 or 2 or anything. 3. 3 ones are 3. 24. 3 ones are 3. 24. 3 eights are 24. Again you can do with 3. 3 6 are 18. Again you can do with 3. 3 twos are 6. Now 54 can be written as 3 into 3 into 3 means 3 cube into 2 or 2 into 3 cube. This also you can write 2 to the power 4 into 3 into 7. Now first we have to do LCM. What is LCM? Product of the greatest powers of each prime factors of given numbers. What do we have to do? We have to do LCM. What is LCM? LCM. What is LCM? Product of the greatest powers of each prime factors of 336 and 54. Now, see what is the greatest power of each prime factors. What is the greatest power here? 2 to the power of 4 is there, 2 is there. You have to take greatest power. 2 to the power of 4 you have to take. Next, you take 3 is there, 3 to the power of 1 is there, 3 cube is there. We have to take greatest power. What is the greatest power in these two? 3 cube. We have to take 3 cube into. Next, 7. What is the greatest power? 7. Only 7 is present. That's why you have to take 7. You multiply 2 to the power of 4 into 3 cube into 7. We will multiply. 2 to the power of 4 means 16. It can be written as 16 into 3 cube means 27 into 7. You multiply these 3, you will get 3024. Now we have to do HCF. What is HCF? Product of the smallest power of each common factor of given numbers. We will write HCF. What is HCF? Now what is HCF? Product of smallest power of each common prime factors of 336 and 54. Now we have to take smallest power of 336 and 54. What is the smallest power? It should be common in both. Here it may not be common. In LCM 7 is not common, but I have taken 7 as common. But in HCF it should be common. Smallest power of each common prime factors means 3 is there, 3 cube is there. It should be common in both. I have to take smallest power. Now you have to take HCF is equal to, we have to take smallest power means 3 should you take 3. What is the smallest power in these two? 2 is the smallest power. 2 is there, 2 to the power of 4 is there. You must take 2. 2 and you see 7 is not common in 336 and 54. That's why we should not take 7. LCM is 3024 and HCF is 6. Now what I have to do? We have to prove product of LCM and HCF is equal to product of the given numbers. What is LCM here? 3024 implies into what is HCF? 6 is equal to 336 into 54. You take LHS. 6 4s are 24. 6 4s are 24. 6 2s are 12. 12 plus 2 40. 6 3s are 80. You got 18,144. You must get 336 into 54. If you multiply 336 with 54, you will get 18,144. You should remember product of LCM and HCF is equal to product of the given numbers. Hi students, now 8th problem in short questions. What is it? Use Euclid's division lemma to find HCF of 306, 306 and 657. HCF means highest common factor. We have to use Euclid's division algorithm. Euclid's division lemma. Lemma is nothing but it is a proven statement to prove other statements. Euclid's division lemma is a proven statement to prove Euclid's division algorithm. Already I explained Euclid's division lemma and also algorithm in basic concepts. Even though I will tell you what is A, B, Q, R. A is dividend, B is divisor, Q is quotient, R is the remainder. You see, what is Euclid's division lemma? If you divide A dividend with divisor B, you will get quotient and the remainder is R. You see, you know dividend is equal to divisor into quotient plus remainder. You see, A is equal to BQ plus R. See, here AB and AB are positive integers. Q and R, they are whole numbers, and R should be greater than or equal to 0. This is equal to 0 or greater than 0, and remainder must be less than B. Remainder must be less than the divisor. R is greater than 0 and it should be less than the divisor. Therefore, A is dividend here, BQ divisor into quotient plus remainder. The remainder should be greater than 0 and less than the divisor. That is Euclid's division lemma. Before going to do HCF, you should understand what is Euclid's division algorithm. We have steps. If R is equal to 0, the HCF is divisor. Means, I will explain you. I want to make you understand. If 6 is divided by 2, 2 3s are 6. What is the remainder you are getting? Remainder is 0. Then, what is the divisor? What is the HCF? Divisor is the HCF. If you divide 9 with 2, 2 4s are 8. You are getting remainder as 1. If R not equal to 0, what do you have to do? You have to continue the process till the remainder is 0. Again, what do you have to do to find HCF? Again, you have to continue the process to find remainder 0. See, you have to take 2. Again, 1 2s are 2. You are getting remainder as 0. What is the HCF of 2 and 9? That is 1. This is HCF. Because you got remainder as 0. Therefore, what is the HCF of 2 and 9? The HCF of 2 and 9 is 1. Already you know 2 and 9 are co-primes. Now, we have to apply the Euclid's division lemma to find HCF of 306 and 657. To find HCF of 306 and 657, it is better to do division method. You have to divide 657 with 306. 2 times it will go 306. 306 into 2. 2 6 are 12. 2 3 are 6. 5 you are getting 4. You are not getting 0 as the remainder. Again we have to apply Euclid's division lemma to B and R. What is B here? B is divisor and R is remainder. Again you have to take this 306 here, 306. How many times it will go? 6 5s are 30. 6 4s are 24. 24 plus 3, 27. You are getting 6 and what is here? 10 means 36. If you are not getting 0, again you have to apply Euclid division algorithm to remainder and divisor, means B and R. You take 36 and 45 here. Again, how many times it will go? 1 time it will go. 15 minus 6, 9. And again you are getting 9 here. Say you take 36. You are not getting remainder as 0. You have to apply Euclid's division lemma to remainder and divisor. 36. 9 4s are 36. Yes, you got remainder as 0. Therefore, what is HCF? HCF of 306 and 657 is 9. Divide 657 with 306. We get 657 is equal to 306 into 2. 306 into 2 plus what is the remainder? You are getting 45 is the remainder. You see, you are not getting remainder as 0. Again, what I have to do? Apply Euclid's division lemma to get 0 to B and R, means divisor and remainder. Now what I have to do? Apply Euclid's division lemma to 306 and 45. To 306 and 45. We get 306 is equal to, say, 45 into 6. 45 is the divisor, 6 is the quotient. What is the remainder you are getting? 36 is the remainder. See, 45 into 6 plus 36. You are not getting remainder. Again, you have to apply Euclid's division lemma to divisor and remainder. And what you have to do? You have to apply Euclid's division lemma to 45 and divisor and remainder 36. We get, what we are getting? 45 is equal to 45 dividend is equal to 36 divisor into quotient. What is the remainder you are getting here? 9 is the remainder. See, you are not getting remainder as 0. Again, what I have to do? You have to apply Euclid's division lemma to B and R, means divisor and remainder. What is the divisor? 36 and 9 remainder. This is remainder. We get 36 is equal to 9 4s are 36. 9 into 4 plus divisor into quotient plus remainder. What is the remainder you are getting? When you divide 36 with 9, you are getting remainder as 0. As we got remainder as 0, therefore 9 is the HCF of 306 and 657. We got remainder as 0. Therefore, 9 is the HCF of 306 and 657. Like this you have to do. It is easy method to find out HCF, but you have to apply Euclid division lemma to find out the HCF of two given numbers. Now what is ninth problem? Show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is integer. Even numbers are 2, 4, 6, 8 like this. They are in the form of 2q. q belongs to integer. You see, if you take 2 into 1, say 2q, q is integer. It can be written as 2 into 2. 6 can be written as 2 into 3. 2q, q belongs to integer. 8 also 2 into 4. 2 into q, q means integer. 4 is an integer. Like this, you know, even numbers are, they are in the form of 2q, where q belongs to an integer. Odd numbers are 1, 3, 5, 7 like this. They are in the form of 2q plus 1. Odd numbers, even numbers are in the form of 2q. Odd numbers are in the form of 2q plus 1. You see, 2 into, what is q here? 0 plus 1. Q is integer. That's why it can be written as 2 into 0 plus 1. This can be written as 2 into 1 plus 1. 2 into 1, 2. 2 plus 1, 2q. Q belongs to z plus 1. See, what is the remainder? 1. It is in the form, 3 is in the form of 2q plus 1. 2 into 1 plus 1. 5 is in the form of 2 into 2 plus 1. 2q plus 1. Like this, like that. Again, 7 can be written as 2 3s are 6 plus 1. 2q plus 1. Q belongs to integer. Like this we know even numbers are in the form of 2q. Odd numbers are in the form of 2q plus 1. But we have to prove using Euclid's division algorithm. What is Euclid's division lemma? A is equal to bq plus r. R should be greater than or equal to 0 and less than 2. Even number. You see, this is divided. A is divided. It is divided by divisor b. Remainder should be greater than or equal to 0 and less than 2, because remainder is 0 or equal to 1. Because here remainder is 1 and remainder is 0 here. 2q plus 0. That's why remainder should be greater than or equal to 0 and less than 2. We have to take remainder as 0 and also remainder as 1. Now you take even number, we have to prove. A is equal to bq plus r. You apply Euclid's division algorithm. See, A is equal to 2q plus first you have to take r is equal to 0. If r is equal to 0, you are getting the even number is in the form of 2q, where q belongs to z. Therefore, even integer is in the form of 2q. Q belongs to z. Now, odd number. Now we have to take r is equal to 1 because it is in the form of 2q plus 1. R is remainder. Now, r is equal to 1 we have to take. A is equal to bq plus r. A is equal to, b means we have to take 2. B, always remember, b is 2 here. This is b. You have to take b as 2. That's why b is equal to 2 and q plus remainder is 1. Therefore, odd number, odd integer is of the form 2q plus 1, where q belongs to z, integer.